if they turn into max or min. Okay, perfect. So of course you found the first derivative as 6x squared minus 6x minus 12. And we know that critical numbers come from two possible sources, either when the first derivative is 0 or when it's undefined. It's a polynomial, so there is no discussion there. Do not ever omit this, because on polynomials it's okay, but on other functions it may not. Okay? So of course, you know me, I like to simplify things as much as possible. I will definitely divide by 6. And then I get x squared minus x minus 2. And then I factor easily. And I got two critical numbers, x equals 2 and x equals negative 1. That's all you needed to do for this exercise. Now, I'd like one step forward. So f prime of x and f of x. We know it's a polynomial, so it has to be defined everywhere. So all I need is the negative 1 and 2. Be very careful. They have to be in the correct ascending order. You have to show 0 under the first derivative. You have to plug this in the function, negative 1 in the function and 2 in the function. We'll do that right now. I have the calculator ready. So in y equals, you know me, that's my preference. You develop your own style. But my preference is not to punch in, punch in, punch in. It's easier for me to present the function or enter the function. 2x to the third minus 3x squared. And then minus 12x plus 1. And then just plug in exactly what I need. I only need negative 1 and 2. So it's 8 and negative 19. Yeah. Good. At this point, I will study the sign of the derivative. You can, if you want, you can punch this function in the graphing calculator. And after you put it in, plug in negative 10. When I plug in negative 10, this is positive, and then this is too small. When I plug in 0, I get negative. When I plug in positive 10, I have 600 minus 60 minus 12. Of course, it's positive. Honestly, this is not how I do it. I know that this is a quadratic function. The derivative is a quadratic function. It opens upward, and it crosses at negative 1 and 2. So to the sides, it must be positive, and right here in between must be negative. I don't plug in numbers for something like this. But that's the easiest way. Plug in a number, plug in a number, plug in a number, and get. So obviously, what type of point is negative 1, 8? And what type of point is 2, comma, negative 9, 19? So negative 1, comma, 8 is a point, and 2, comma, negative 19. What are they?
A maximum and then a minimum?
Yes, a relative max and a relative min. The derivative is either 0 or undefined, and it changes sign specifically in this way. So it must be a relative max. It's the first derivative is 0 or undefined, and it changes sign specifically in this way. So this must be a relative min. Awesome. Good. Now we want to continue with problems from this section. No, not this. Problems from this section, in which we will determine again everything we've studied so far. Increasing, decreasing, max, min, intervals of concavity, and inflection points. If they exist, of course. Anyone would like to choose? So last time, I think we only had one example from this. Yes, we only had one example, and that was I have no idea. 21. Who would like to choose, or I will? You know me, I don't like to waste time. 1,
26.
26. You saved me from choosing. Thank you. Very good. So f of x equals x squared natural log x. Perfect. Good. So we want the whole thing, everything we've studied so far. We were going to study the first derivative with everything and the second derivative with everything, and we're going to put everything in the favored table, or famous. Okay? We have to start with the domain. At any point in time, if the function is not, even here, the function is polynomial, we didn't discuss that. We skipped that because this is very clear. But this is not a polynomial function. So I have to start with the domain. Can anyone tell us what is the domain of this function? Let me push my computer further away from me.
X has to be greater than 0.
Exactly. Awesome. Because this is not a friendly function. Thank you. It's not what I call friendly. I have to worry about it. Awesome. So I start my table. F prime, f of x in the middle, and the second derivative. This is the domain, so I'm going to write it here again. Open parenthesis, 0 to infinity. 0 to infinity. Notice what I'm going to do next. Which means I cannot plug in 0 in the function, and of course I won't be able to plug in 0 in the derivative or first or second. So there is nothing here. I cannot put in any number in there. Okay, perfect. Now, I need to find, first of all, my first step is to find everything about the function that I can without the help of the first and the second derivatives. So first, what can I find out? I can find out this limit. I can find out this limit or determine that limit, and x and y intercepts. That's all I can find. This limit here, and x and y intercepts. Since I cannot plug in 0, there is no y-intercept. No y-intercept. Is there an x-intercept? So let's analyze. I'm going to copy the function right here. So f of x equals x squared natural log x. Can x squared natural log x be 0? This is the question now.
No.
Say it again.
Oh, can it? No.
So first of all, this one, even if, one possibility is x equals 0, but that's not a possibility. We already know the function doesn't exist. The second option is natural log x equals 0.
Oh, yeah. Okay.
Exactly. So because it's a product, either this is 0, which would give us two solutions, x equals 0, and a natural log x equals 1. That's the second option. Which x makes natural log 0?
1.
Yes. E to 0 equals x. E to 0 equals x. And e to 0 is 1. So 1 and 0. Now I have to find this limit, and I have to find this limit. And I'm done with the function. The function will be exhausted. I cannot find anything else. Only these limits and x and y intercepts if they exist. Okay, so then I have to find the limit of x squared natural log x as x approaches 0 only from the right. X approaches 0 from the right. So when x approaches 0 from the right, this approaches 0, and this approaches infinity, negative infinity. This is one of the indeterminate cases. So if you remember last time, I listed here 2 ratios, 1 difference, and 1 product. That product is 0 times infinity. Even if it appalls you, you're appalled and say, no, 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 0 times infinity is 0. No, it's not. This is 0 and this is a symbol. So 0 times infinity may be 0, but it may not. So it's an indeterminate case. Indeterminate case means no clue. Anything can happen. So we did not get to discuss this. This is in the next section in 4.4. And I don't want to spend time on this right now because we're going to get to 4.4 and I'm going to come back here. So for now, I'm going to just leave it alone. So we're going to come back today, but later. So I have to find the other limit. So this is limit of x squared natural log x as x approaches infinity. There is no problem here. This approaches infinity. This approaches infinity. Infinity times infinity is infinity. At this point, we are ready to discuss the first derivative. So this is the only thing that we cannot, for a few minutes, half an hour, we have to wait on that. Okay, first derivative. Take it back. Which rule is applied here?
Product.
Thank you. So the first function prime, 2x times natural log x plus x squared times natural log x prime, which is 1 over x. So then we have 2x natural log x, and I simplify, and I get plus x. This is the first derivative. Now we have to find critical numbers. Without critical numbers, I can't continue. And critical numbers, as we know, they can come from the first derivative being 0 or the first derivative being undefined. Well, this is undefined where the function is undefined. So now I have to solve this equation. So let's continue. I'm going to write it one more time because I ran out of room. I always run out of room, don't I? So 2x natural log x plus x equals 0. Any suggestions, any recommendations? What would you do here first?
We could take out x.
Of course. We cannot divide by, I know you didn't say that. We cannot divide by x, but we can factor out, because one factor could be 0 and the other factor could be 0. There is no point because 0 is not in the domain. It does not belong to 0 to infinity. It's not in the domain. Goodbye. But this I can solve. Moving 1 and dividing by 2. So I have natural log equals negative 1/2. Now I have to convert this into exponential. How do I convert it into exponential?
You do e to the power of negative 1/2.
Excellent.
Equals x.
Yes. And I will get this right away because I have no idea what it is. So it's e, and the power is negative 0.5. I got 0.61. Quickly to the table. 0. And now study the sign. Studying the sign of this. So if I put 10, 2 times 10 is positive, natural log of 10 is positive, plus 10 is positive. No question. But now I have to put in something like 0.1. 0.1. Okay? And see if it's negative. So I have 2 times 0.1 times natural log, which will be negative, of 0.1 plus 0.1. I got negative 0.36. Okay, good enough. I don't care about the number. I only care about the sign. Now I have to plug this in the function to get this point. Okay, where is my function? Who knows? Right here. So here's the function. So I have in y equals. Yeah, let me do that because that's a different story. I need that for the second derivative anyway. When it's something simple, just plug it in, I'll do it, but otherwise I have to show it. Okay, so in y equals, we have x squared natural log x. Natural log x. Oh no. X squared natural log x. And I will plug in 0.61. I know that negative 1 is an error. You don't have to scream at me, Mr. Calculator. Okay, got it. So we have negative 0.2. Yeah, very nice to graph. We are not graphing though. Okay, perfect. So we don't know, but this is probably, I didn't calculate anything, I said later. So this is probably coming from infinity. It will be decreasing to negative 0.2 and then increasing to 0 and increasing to infinity. We're going to discuss this later, as I mentioned. So clearly, what type of point is 0.61 comma negative 0.2? I have to write it right here. Can anyone help? 0.61 comma negative 0.2. What type of point is this?
A relative.
Yes. Yes, indeed. It's a relative minimum. Now, if I ask, what interval is this function decreasing on? What will you say? The function is decreasing on?
0 to 0.6.
Excellent. And it's increasing on?
From 0.61 to infinity.
And they all have to be open parentheses. Awesome.
Yes.
So this is a relative minimum, 0.61 comma negative 0.2. And the function is decreasing between 0 and 0.61 and increasing between 0.61 and infinity. Awesome. Now we are ready to discuss the second derivative, which gets more and more complicated. Maybe, maybe not. We'll see. So I'm going to copy f prime of x here. You don't have to copy it again. It's easier for me to copy it and find the second derivative. Let me see how we are on time. Yeah, let me stop this video.